What if the whole next revolution in computing isn't just about making our infrastructure invisible? What if it's about completely dissolving the very idea of an application as we know it, breaking it all down into a fabric of intelligent functions that are just woven into the network itself? So today, we're diving deep into the world of serverless computing. But look, we're not just going to talk about what it is. We're going to explore its really radical trajectory, how it went from a clever solution for idle servers to a future that could fundamentally change everything about how we build and interact with software. Okay, so to really get why serverless was such a big deal, we have to go back in time. We have to understand the world it completely disrupted, a world where the cloud was, yeah, powerful, but also incredibly wasteful. The whole history of cloud computing has kind of been this steady climb up a ladder of abstraction. We started on premises, right? You had to manage everything. Then came infrastructure as a service, or IaaS, where cloud providers handled the physical boxes. A step higher, you had platform as a service, or PaaS, which took care of the operating system. And with each step, yeah, we offloaded work, but a really fundamental problem stuck around. Here's the thing. Companies had to buy and set up enough servers for their absolute peak traffic. Think Black Friday. But most of the time, that traffic just wasn't there. This created what we call the tyranny of the idle server. This huge, massive gap where businesses were paying for expensive compute capacity that was literally just sitting there doing absolutely nothing. And this wasn't just about money, it was this huge operational tax. It meant your best, most expensive engineers were spending their days not building new features, but managing complex scaling rules, patching operating systems, and wrestling with the insane complexities of things like Kubernetes. All of this was just heavy lifting that did nothing to actually move the business forward. So the market was absolutely desperate for a new model, something that would solve that waste problem and get rid of the operational tax once and for all. And then in 2014, a new paradigm emerged that promised to do exactly that. After years of building up the cloud with IaaS and PaaS and containers, the pivotal moment finally arrived in November 2014. Amazon Web Services launched a service called Lambda. And this wasn't just another step on the ladder, it was a leap into a completely different way of thinking about computing. This, right here, was the catalyst. So what made it so different? Well, the first and most famous principle is no server management. From a developer's perspective, the server just vanished. All the patching, all the scaling, all the maintenance became the cloud provider's problem. This gave rise to a whole philosophy called no-ops that basically let developers just focus on writing code. Next up, execution became entirely event-driven. Now, unlike a traditional server that's always on, always running, a serverless function just lies completely dormant. It only wakes up and runs its code when a specific event happens, like an API call comes in, someone uploads a file, or a row changes in a database. It's a fundamentally reactive and way more efficient model. Third, these functions are ephemeral and stateless. The environment that runs your code might only exist for a few milliseconds before it's completely destroyed. This means it can't store data locally. And this isn't a bug, it's a feature. By forcing all your permanent data into external databases, the platform can scale each function totally independently to insane levels. And all of this leads to the fourth and maybe the most disruptive idea of all: pay-for-value billing. You are billed only for the milliseconds your code is actually running. If nothing is happening, you pay nothing, zero. The tyranny of the idle server was, just like that, finally solved. Your cost was perfectly aligned with the value you were delivering. And the results? Well, they were staggering. Coca-Cola cut the operational costs for its IoT drink dispensers by 66%. The financial regulator, FINRA, actually doubled its cost efficiency while analyzing 75 times billion market events every single day. And T-Mobile, with its serverless-first strategy, saw an 80% drop in application-related issues. Just incredible numbers. But of course, this powerful new model wasn't a silver bullet. This massive leap in abstraction, it came with its own set of very real trade-offs and challenges. Because there's always a catch, right? And in the world of serverless, two big ones have really defined the debate for the last decade. First, you have the infamous cold start. See, if your function hasn't run in a while, the platform has to create a whole new environment from scratch. This takes time. It has to download your code, start up the runtime, and all of that adds up to latency. For a background task, a few hundred milliseconds, maybe it doesn't matter. But for a user waiting for a web page to load, that can feel like an eternity. And second, there's this major strategic dilemma. The incredible speed you get with serverless comes from tightly integrating with a single provider's entire ecosystem, their databases, their queues, their functions. This creates this beautiful, really productive walled garden. But that deep integration leads to vendor lock-in. The alternative is something more like a mycelial network, an open, interconnected system that can run anywhere, but that means giving up some of that wonderful simplicity. And this brings us to our final act. See, the compromises we're making to solve problems like cold starts and vendor lock-in, they suggest that the serverless we know today isn't the final destination. It's really just a stepping stone to something far more radical. So here's the core thesis. Serverless isn't the end game. It's a transitional phase. Its ultimate trajectory is towards a future that people are starting to call ambient computing, where computation is just invisibly embedded everywhere, in the very fabric of the network around us. So how do we get there? Well, the key enabling technology seems to be WebAssembly, or Wasm. And just look at this comparison. It shows you why it's such a game changer. Where containers are slow to start, Wasm is nearly instant. We're talking under a millisecond. Where containers are tied to an operating system, a Wasm binary is truly universal. And its secure sandbox model directly solves the core technical problems of serverless that we have today. Okay, so what does this Wasm-powered future actually look like? Well, it's a world where the idea of deploying an application to a specific region in the cloud just becomes obsolete. We're already in what you could call the Wasm inflection point, where it's becoming a real alternative to containers. The next phase is likely going to be the edge-native default. Instead of deploying to a cloud region, you'll deploy just once, and the platform will automatically distribute your code to hundreds of locations on the global edge. And then, beyond that, we could see the rise of ambient intelligence, where the network itself becomes a proactive, autonomous computer. Which brings us right back to that central dilemma. Is the future of software a series of these beautifully productive but confining walled gardens? Or is it an open, interconnected global network, powered by portable technologies like WebAssembly? Honestly, the next decade is going to decide which path we take. The question isn't about getting rid of servers anymore. It's about what we build once the application itself disappears. Let me know what you think below.